Transport Police were only actually in the structure as a coincidence on the day of the fire. So the incident was initially found by a member of the public, and 5 minutes later they stopped the escalator. Now at this time, a member of the London Underground staff received a report and went to investigate. He went to the wrong place. He was given bad information. Now, at the same time, 2 officers saw the actions. They got a cue from a member of the public and then went to investigate. So during this period, the British Transport Police were active. They confirmed the fire, made some calls, and then requested the station staff to send passengers via the Victoria Line escalator, so to circumnavigate the incident. However, unbeknown to them, both escalators ended up in the same place, which eventually suffered a flashover. So eventually, some 13 minutes later, a station inspector went to the upper escalator machine room and saw the fire, and then attempted to try and put it out unsuccessfully. The police then made a decision to evacuate the area, called London Underground and asked for the trains to be stopped, and then asked a station staff member to make a similar call. Now, this is now some time later. They continued to try and put the fire out, and then controllers sent the order to the Piccadilly Victoria Line to stop the train. So basically, all that time, just as you saw in the example this morning, when people were still entering the shop, people were still entering the station. At 7:45, the flashover took place, engulfing the ticket hall. And again, up to this point, people were still entering the ticket hall from below as part of the evacuation procedure. Here, there were issues with communication, with conflicting responsibility. There were at least 2 groups of people here addressing the incident, and with the notification process. This is just another quick example of a train incident in the Tokyo subway attack in Japan, where again there was much confusion, much misunderstanding of what was actually going on. 5 trains on 3 lines were attacked by members of the armed cult. The attackers affected 15 different stations, and 12 people died, with thousands of people affected. Now this was, and deliberately so, a complicated event. It would have been difficult to manage at the best of times, but there was much confusion and much misunderstanding over the nature of the event, how severe the event was, and then what the staff should do to combat it. So in the examples we've seen already, there was a relatively simple procedure in the Japanese incident, Japanese fire. The delays, the short delays, had a serious consequence. In the King's Cross fire, it was a very convoluted procedure, informal procedure, that had a very serious outcome, and here it was almost there was no sufficient procedure in place. Now some exercises were conducted in Ulster, where they evacuated some large department stores. This involved over 2,500 customers and 100 members of staff over several exercises. Now from the video footage, they worked out that basically it took the staff approximately on average 18 seconds to respond, ranging up to a minute. And so it was an unannounced drill, so the alarm went off, and there was a procedure for the staff to act, given that they heard a general alarm. But even in this case, it was, as I say, open plan retail stores. The alarm goes off, it still took them some time to process what was going on. For the customers, it took on average 30 seconds to respond, up to 100 seconds. But this was because they were largely dependent on members of staff to come and inform them of what was going on. So they heard the alarm, needed a second cue, as there was no smoke, to confirm that they needed to evacuate from the store. And they also reported that 80% of the staff had an impact on customers' response. So this indicates the importance, even in a very simple incident such as this, the importance of staff activities on subsequent response of the evacuated population. Typically, we don't just immediately evacuate, this is well understood, but we depend on secondary cues after the alarm, and if there's an initial delay in the staff response in the first place, this has a significant knock-on effect. Here we go. So, what myself and my co-authors came up with was this concept of responses. But if we know the procedure in place, and we can estimate the basic number of decisions that members of staff need to take. Now, as it stands in the engineering process, we do this for non-staff. We say, if you hear some cues, it takes X seconds to begin to evacuate, and then Y seconds to reach a place of safety. And we do this either through engineering calcs or look-up tables or simulation tools. So all I'm saying here is we should have a comparable system for the members of staff, given that we know the procedure in place. So what I'm saying is every time that a member of staff makes a decision, we add a delay time that then delays the initial response of the non-staff population. And we can also, in the same way, attempt to simulate the time it takes to perform actions. So it may be that staff has to go and confirm an incident. How long does it take them to get there? We can work that out. We do the same thing for the members of the rest of the population. As I said, staff errors are not addressed. That's an entirely different problem. And we don't account for that in the evacuation process in general. So my colleague and I broke down this system, if you like, into three core elements. What's the mode of detection being used? Is it just a sensor goes off and then sends a signal? Is it a member of the staff that recognises the incident? Or is it a member of the public? Secondly, how is the information disseminated once the sensor has been enacted? Is it a general alarm, so an immediate general alarm? Is it a local alarm, so in the immediate area of the sensor going off? Or a private alarm to other members of staff? And finally, is confirmation required? None is required. You can do it by CCTV or remote observation, or you physically have to send someone down there. Now, obviously, each of these different settings has a different requirement of the staff, and therefore a different potential for delay. So some of these, for instance, the manual confirmation will require somebody to receive a message, process that information, and then go and check it out. That has a different impact on the delay to the general alarm than if the sensor went off and the general alarm is sounding. Then, of course, we still have to calculate the evacuating population. I'm talking about the time that calculation can start. So we came up with this slightly horrendous looking table, where basically, you can see here are the three variables. And here we have the detection method that's assumed, so whether it's a sensor, a member of staff, or a member of the public. The mode of dissemination, excellent. And the mode of dissemination, whether it's a general alarm, local alarm, or private alarm, that is, it goes to a control room somewhere. Or whether confirmation is required, so whether it's not required, whether it can be done remotely or manually, somebody has to physically go there and look at the file. Now, given these different scenarios, if you like, we've estimated the number of decisions required. So, how many times does the staff have to process information? Also, you can work out the number of actions that they're required to perform in order to conduct so moving, communication, and so on. And I'll give you a couple of examples to demonstrate. So here, we look at the first example, so the first in the red box. So, fire's been detected, it's been sensed. Sensor enacts a fire alarm, the fire alarm goes off, and the public's is a general alarm. So there's no, if you like, staff activity in this process. There's no decision making in terms of the staff. And let's go back and look at this example, where there are sensors, there's a private alarm, and manual confirmation is required. So in this example, the system has a sensor that detects throughout the structure. It alerts a private alarm that goes to a control room, heads down, and that requires some understanding of the signal. The member of staff looks at the signal and says, oh, it's really as a fire. They then can communicate, so there's an action there, and they communicate with another member of staff to go and confirm. So there's some actions there and some more processing